So good morning, ladies and gentlemen. I would like to welcome you here at the Czech University of Life Sciences, especially at DevFest. We're so pleased to have you here. And I would like to mention some organization info again if you missed the keynote, but I believe you didn't because it was awesome. For questions for our speakers, we're using Slido. It's slido.com and use the hashtag DFT1. You can submit your questions for the speakers and we're going to answer them after the talk. Then we have some few slots for lightning talks if you'd be interested at the end of today. So you can use also Slido with DFLT, I believe. Then after the talk, if you have any questions for the speaker, I would like to ask you not to ask him here in the auditorium, but we have a speaker's corner right on the right side outside the room. And now I'm not gonna take any more time for you, and we're gonna start ahead with our first speaker, who is engineering lead for Dart at Google in Denmark, who's actually like pretty big start, and we're so excited he accepted our invitation. He is a marathon runner, a father, an amazing person, and I would like to give a warm applause for Kasper Lund.
Thank you so much. Let's see if we can get the slides to work. Yes, it's on. Thank you very much. It's great to be here, and thank you for the introduction. So I want to just elaborate a tiny bit on that introduction and give you a little bit more sort of insight into the kind of things I've been working on. That's not all of it. I do work at Google, and I worked at Google for some would say too long. 11 years, it actually has been a very fun ride. And I joined the company right around the time when we were starting to work on a product that I think most of you know, Google Chrome. How many people here know of Chrome? Okay, that's good, very good. So I worked on a small part of Chrome. The first project I started when I joined the company was at that point, an unknown project for most people. I think today people have heard about V8, which was the JavaScript engine we introduced in Chrome. And that was a very fun project to start and to work on for a good number of years. Since then, I've moved on to do even more ambitious things in the context of Dart, and that will be the primary focus of this presentation. So if you do have questions about V8 and the history of all that, find me in the hallways. I'll be here. So today I'm here to tell you about possibly the best way to build for mobile. And before I sort of dive into like how I think we should be building for mobile, I just want to give you a small sort of motivation for why it's important. So maybe this is a bit of an odd slide. How many people here know these two gentlemen? I have a few people. I can tell you that maybe the most famous one here in Europe is Barack Obama up in the corner. But the other guy in the lower corner is Dick Cheney, his sort of political opponent through many, many years. What do you think they have in common? Anyone? Almost nothing? They do have something in common. I don't know if this is a hint for you guys. Does this change it? Do you know what they have in common? Not really? This is what they have in common, and maybe this is the only thing they have in common. Hamilton, it's a musical in the US. It's a big thing, and apparently that's probably the only thing that they both like. So Hamilton is a big show in the US, and if you have a really popular show, what do you need then? The only thing that's missing if you have a truly popular show is a mobile app to go with that show, clearly. And it has to work on Android, it has to work on iOS, and it has to look just right. It has to sort of embody the feel of the show. So it has to be a very special, great working app, so that the extension of the show on your cell phone. So the actual question is, like, when do you need that app? And you need it now, of course. People are super impatient in this business. Like, the show is going really well. You want to use that momentum and just, like, run with it. So the challenge is, like, you need to hurry up and build not just one great app, but 2 great apps and ship it. High quality, has to be right. So to do that, you need a super productive environment, a framework, everything that supports delivering an app really quickly. You also need a platform that supports what I like to call custom UIs really well. So UIs that are not necessarily sort of the standard widgets of the platform, things that look more like things you would expect if you love the show, and less like a standard iOS app. And you need a high-performance solution, of course, so it doesn't come with compromise. You can ship an app that just looks right from the get-go. Of course, I'm here to tell you that there is a solution that might sort of approximate this. I'm going to tell you the details of that. And that solution is Flutter. Flutter is a rather new technology. It's built primarily by people from Google, but there's a growing set of contributors to it on the outside as well. It's open source. It even has a logo, and you see it right here. And Flutter fits into the broader picture I think in a very nice position here. So you're probably very familiar with iOS and Android SDKs. How many people here use those on a daily basis? That are the native. Okay, so you know what I'm talking about here. So they compile to native code, where native is a little bit overloaded here. Some of them compile to Java bytecode and Dex bytecode. iOS compiles directly to native code before you deploy. But for some people, this is a bit too rigid, a bit too slow tool chains to use. So people have been exploring using sort of more interpreted solutions, still based around some of the same core UI paradigms in the model view controller space. And that usually ends up looking like Cordova, PhoneGap, Ionic, those solutions. They're more flexible. Some people prefer them. They're faster to use for some people. So there's definitely a choice you can make here. Like the new kid on the block here is probably React Native, which fits really nicely in the corner here, if I can get it to show. Yeah, your code is written in JavaScript. It's interpreted on the device, but it still uses sort of native components, but it has a different paradigm for constructing a UI. Essentially, you try to map your current state to the representation you want it to have on the screen, and that's sort of the core model. You're not manipulating the individual views and the representations directly. You more do this simpler, somewhat functional mapping. Flutter fits in this picture, in this remaining square. I don't know why I decided to give that a bigger font. Maybe that's just me. But anyway, it's not bigger yet, but Flutter certainly fits in here. It's a solution that is using a reactive sort of functional framework, and it compiles to native code at deployment time. So when you ship an app written in Flutter, you are shipping native code for the platforms. So if you dive into what makes up Flutter, it looks a little bit complicated. Many layers and many different sets of things go into Flutter. But at the core of it, there's the C++ part, which consists of Skia, which is a pretty well-known, maybe actually not that known, but very highly used 2D graphics library. It's used for Android and for Chrome, for all the graphics there. Hardware accelerated, of course. There's a text component. Turns out layout of text is super complicated. If you want to make it look right, you have to invest a ton of time in building a component that makes it look exactly like it should, with all the padding and wrapping. Everything has to be right, and that's complicated. So we stole that from somewhere else, and initially we had a good implementation of that in our browser, Chrome. So we just lift that out of that and put that into what we call the Flutter engine here. The last component is the one I'm most familiar with, is the Dart component. It's a runtime for running programs and framework parts that are written in Dart. So the rest of the whole stack here is written in Dart, and it's a very layered approach. So at the bottom of it, you have sort of foundational pieces, and you have support for animations, painting, rendering, all those things. And then as we approach the top of it, we are getting into the widget space, and it comes with a beautiful set of material design widgets, among other things. So you have this layered approach to building software, and as a developer on the Flutter stack, you have the opportunity to sort of target the layers that make sense for you. Everything here is essentially user code. It's all written in Dart, so you can see it, you can change it, you can manipulate it, and you're not constrained by it. So if it doesn't work for you with a general way, say, the widgets work, you can do your own framework on top of that part. And that gives a lot of strength. It allows people in this audience and people on my team to move quickly, try alternatives, and not be constrained by having this sort of monolithic piece of software that nobody knows how to change. So if we dive into the material part, for many people building apps, having a great set of built-in widgets is super important. This is just a small piece of the entire material catalog that is available on Flutter. And what you'll notice if you actually see it from the back of the room here, they're quite small. But it's not just sort of traditional widgets that are in here. Flutter uses oh, I'm being turned up now. Perfect. Is that better? Maybe. Anyway, Flutter uses widgets for not just the traditional sort of UI elements, but also to control the layout of them. So we have widgets that deal with padding or centering of of content on the screen, and we have widgets that are sort of more traditional controls, UI controls. So I think for me that, I'll show you the code and show you how that looks like in practice in a bit, but it's really nice to have this set of built-in constructs that make it easy to build high-quality, high-performance, great-looking apps. So it's easy to just talk about these things. I want to try to show you, and it's always dangerous to do live coding and whatnot, but we'll try it anyway. So the way I can run here a Flutter program, I can use the command line tools to actually build and run a small gallery of Flutter UI components and show you how that looks on an emulator. If I can find the emulator as well. Let's see. That was hiding here. OK, so we have it running here on the side. If you pay attention to what's happening in the console, you can see we're actually using Gradle and like all the other built-in parts of the Android SDK and using that to build and deploy this thing to the emulator. So we're piggybacking on the tool chains that already exist. But the result is that you have this app running here in the emulator. It has all the kinds of things you would expect from a material design, if I can interact with it, application. And it comes with a lot of easy to steal, use, explore examples of code. Not super exciting on its own, but it's kind of nice to see that this thing is kind of easy to get up and running. The one thing that might stick out here is the 27.2 megabyte app for this small thing. This is the debug build, so it's way bigger than the one we pushed to production. So I will return with more details in a bit, but essentially there is a command line tool that allows you to look at the number of devices you can deploy this to. This works beautifully on real devices as well, and you can run these things on the device. It's pretty simple. People are starting to notice that this thing actually works really well, and one of the things that people pick up on is the fact that the material design widgets that are put in there are really high quality. So that's a very nice thing that people are using this, trying it out, and getting a good experience from that part. So one problem with having a set of widgets that are built in, like material design widgets, is that apps like Hamilton, but I would say many, many popular apps are actually starting to use what we call custom UI, sort of brand-specific UI elements that look slightly different than what you expect from a normal iOS app or Android app. And we see applications that look a bit like this, for instance, where the interaction model, the animations are not sort of native things you would expect to see in any app. But they're getting quite popular. Like there are even things that are slightly more sort of involved than that. And we see a lot of this. In Denmark, some of the most popular apps there actually have a very sort of brand-specific UI. There's a mobile payment solution in Denmark called Mobile Pay, not surprisingly, I guess. And that actually also has a different model for showing the UI. It's not sort of standard widgets anymore. And one challenge, I think, with custom UIs is that there's a lot of pressure on delivering these things. And it's really hard to do it. This is one area where if you go to a consultancy and say, I would like you to build an app for me, they will probably ask you, like, how custom does the UI have to be? Because it's expensive to build these things at high quality. And one thing is that it's expensive and hard. It's also really painful to do it twice for iOS and for Android. So if you invest time in building something that looks beautiful on Android, and then you have to do the same thing on iOS, that's really painful. And you probably have two different teams doing it, and that comes with a big cost too. So the solution that we have in Flutter for this is actually, in some sense, eating our own dog food. So Flutter supports custom UIs extremely well because, in some sense, everything in Flutter is custom. So all the layers here, all the material design widgets are built on the same layers. So to support ourselves in building material design widgets, we've had to add layers that make that like relatively straightforward. So if you're building custom UIs, you have all the right layers here, all the right things you need to actually go ahead and build them in an effective and easy way. Let me try to show you how that actually looks. If we go back here to I can actually show you the animations thing from before, and you will notice that the animations here are quite different what you will normally see. And this was quite easy to build in Flutter. And we do see lots of apps with designs like this that win design awards. These are usually sort of, if you look at like top 25 apps that get awards and high ratings, they tend to be a little bit more different than usual apps. So one thing is that it actually runs here, and that's kind of nice. But I would say that even better is that you can actually say, let me just run this not just on the Android device, but on all devices. And that, of course, includes the iOS simulator as well. You can put them up next to each other. So you'll probably notice that for some reason we started compiling the Android version first. That's a little bit slow. And hopefully we'll now start to use Xcode in the background. You can see that with pod install, Xcode build, and everything. So we're using also on Xcode the tool chain behind the scenes. And hopefully in a few minutes or seconds, we'll have this installed here and fired up next to it. And just to demonstrate that the exact same code here works on this device. And that's kind of a neat thing, I think, that you can build this thing once using the layers that is provided from us. You're not constrained by the widget set, but they can be handy. I can show you just a tiny bit of the code for this. And maybe this code is not super interesting to read, lots of magical constants and whatnot, but I'd like to point to the import statements at the top. We're basically importing the layers of Flutter here, the foundation layer, the material layer, and the rendering layer, and it hooks in at that level and just reuses those packages that are available to do custom UI in a relatively straightforward way. So that's basically the trick here, that we have a layered approach that gives you the same power to do UI as we need to build both the material design components, but also what we call the Cupertino components. Cupertino, if you don't know, is the place where Apple has its headquarters. So these are actually sort of the iOS native widgets that we have available as well. So you can write apps in Flutter for both Android and iOS. If you want to, they can be very different, but you can also share big pieces of functionality, even at the UI level, and that's extremely convenient. So I would claim that Flutter makes it easy to do custom UIs, and you don't have to do custom twice, and that's a major win. I don't know how many of you work in companies that have both an iOS and an Android team, but it's very common. And then like shipping things at the same point in time with feature parity across these things come really, really hard to maintain. And do, like we definitely have had our shares of challenges at Google where like sometimes we just need to ship a new feature on iOS first or on Android first, because that's the way it works when you have two separate teams. It's very hard to sort of keep that all in check. One thing I think it's very important to point out that a good chunk of you in here, like how many people here have tried a cross-platform solution before? A number of people here, and often that comes with a lot of compromise, often in terms of performance. And that's one of the things that we've been very, very aware of from the get-go, that if you want to build a way to do cross-platform, it has to come with no compromise on the performance. It has to be high performance, beautiful UIs all the way down. And to some extent, we've already succeeded with that. At least people find that when they build these things, they find that Flutter is much better in terms of delivering that performance, that necessary performance, in a cross-platform setting. So as the founder of the Dart project and someone who's worked on Dart for almost ever, I think a good chunk of the reason why Flutter works really, really well is Dart. It's certainly not the only reason, but I'd like to sort of give you an insight into like why Dart is a good choice for Flutter and what it enables for Flutter, and hopefully you'll share my excitement about that in a few minutes. So Dart is also something that has a logo. It's actually been around for 6-7 years, something like that. And it's heavily used, but mostly inside Google, I would say. So inside Google, we're basing essentially our entire business on applications written in Dart. So the AdWords relaunch that was just rolled out is all written in Dart. So this is a good place to build technology, to have a customer on the inside that has pretty fantastic revenue. It's also growing really fast inside Google, so we're seeing lots of people pick up Dart and start using the frameworks and the things that we've built. And one thing that's a little bit less scientific and more an interesting number is that the teams report that they're gaining like a 2x productivity out of switching stacks to using the Dart-based stacks. That number is always really hard. Like, what did they switch from? Are they just excited about the new thing? It's hard for us to tell, but it's a good number to get back, and people are excited. And this is not actually in a mobile context where they get a chance to hit both iOS and Android in one code base. This is actually in a web setting where Dart actually translates to JavaScript and runs across all the modern browsers. So this is where we see lots of traction inside Google today with using Dart, and yeah, you'll see much more, many more Dart apps like rolling out from our side. Maybe some of you know Angular. How many people here know Angular? You probably know the TypeScript or JavaScript version of Angular best. If you do care about like learning about the best version of Angular, you should come to Jana's presentation at 2 and hear more about that, and Firebase as well. But within Google, the Dart version of Angular is really heavily used, and the kind of apps we built with that are things like AdSense and these like big enterprise web apps that we earn a lot of money through providing to our to the people that want to buy ad space. So there is this Dart technology that exists. It's heavily used within Google, but I think it's more interesting to take a step sort of further down and look at like what is Dart, how does it all fit together, and why is this a good choice for Flutter? This is actually in a web context. So why does it make sense to have this in a mobile context too? So the Dart language is, I would say that it's unsurprising. It's certainly object-oriented. I've heard people call it a little bit boring. I kind of like that. In some sense, I think that's not necessarily the worst thing for a language to be. It's very pragmatic. It's very usable. Class-based single inheritance, like a lot of very sort of sane, simple choices. Syntax with lexical scoping that is familiar to pretty much everyone who comes from a like C, Java, JavaScript, C++, C# background. I would say the latest thing that we've done to Dart is actually upgrade the type system. So from having a looser type system that has been very good for some people, we've upgraded that to have a more strict and sound type system, and that actually gives us a lot of benefits at scale. And we're seeing people write like multi-million line apps in this with many hundred developers, and then at that level, it certainly seems like this is paying off. I'll get back to where the sound type system also fits in a mobile context, where the apps tend to be smaller than a few million lines of code. But it's certainly like the major upgrade we've done to Dart over the last few years. So the way Dart actually is compiled and deployed is usually using ahead-of-time compilation. So ahead-of-time compilation is kind of an interesting thing. It's I like to think of it as a big sausage maker here. So you have this thing, you throw Dart code in, and you turn that crank, and on the other side something comes out, hopefully an APK or an IPA, not the beer, but the iOS application form. Or you can get JavaScript output out. So you have this big compiler in there, and it has like optimization phases, it has dead code elimination, it has like all the things you would expect in a real compiler. This is not your typical transpiler that just does a lightweight translation from sort of more syntax from one to another. This certainly is an optimizing, minifying compiler, both for the APK and the JavaScript output case. So compilers are sort of super interesting. I've been spending the last almost 20 years working on compilers, and it seems to be sort of a good way of tackling problems, at least for me. I would say it's job security for me, at least. There's always a need for another compiler, and certainly here we have more than one compiler in play, and that works really well for us. So the compiler, just to make it very clear, the output of our compiler here for Android and iOS is actually like real native machine code. And those platforms, it's like ARM or ARM64 code. This small piece of machine code here, maybe someone can venture a guess to what it, no, I don't, it's fine. This is actually an efficient way of computing a hash code, or part of an efficient way of computing a hash code for a double object, but that's a small thing. But it's very like, to the metal, generating the native code, and that's what we embed in the APK and the IPAs when you deploy them. This is the kind of things you would be deploying. So Dart compiles directly to native machine code. Sometimes I use the word native code to mean this kind of thing, but native code is a bit overloaded term. For some people, that means like Java code or Objective-C, Swift or Kotlin for these devices. So I think part of the reason why people find that UIs that are implemented on top of Dart and Flutter are running really, really well is the fact that we actually compile some native code. One of the challenges you have when you're building a compiler is that you need the output to be efficient and small, and sometimes those two things contradict each other. So we're trying to strike a good balance here. We have more work to do in this space. There's tons of opportunities here, but having a compiler that can take a high-level language like Dart, compile it to machine code, and deploy that is a real benefit for us. I'm not sure this is the only reason why like smooth apps exist based on the Flutter stack for Android, but certainly I'd like to think that it plays into this. One of the things you get from having compiled code, native machine code, in the IPAs and APKs is that when people start your app, there's no sort of latency before the app gets warmed. There's no VM that needs to warm up and just in time compile the code. Everything sort of works together from the first frame, so there's no perceived like slowness initially. And some people actually find that on some platforms that makes a huge difference, right? People don't necessarily spend that much time in your mobile app. Like they click it, it has to be live right away, and then it has to be fully functional, not miss a frame from the first second. And delivering native code to the app stores enables that. One problem, though, is that sausage maker is a big piece of machinery. And like for some people, at least, it's very, very complicated and involved to make sausages. So the compiler also takes a long time. So I don't know how many people here have waited for a compiler in their life, but they probably includes almost everyone. I think this is part of the reason why people are going for interpreted JavaScript solutions in the mobile space. They don't want to wait for a compiler for everything. So having told you that Dart compiles to native code with an ahead-of-time compiler, you might have that feeling that maybe this is not very pleasant, maybe it's too slow, maybe it's too annoying to sit and wait for this compiler to come to its senses and produce some code. Maybe you actually saw some of the console output. Right? I was waiting a little bit. It's not great to do a demo where you have to wait like 20 or 25 seconds to see a small app fire up. So it's a little bit painful, right? We have to be able to do better. Luckily, there is a solution to that, and that is just-in-time compilation, where you sort of pay as you go. So you try to avoid compiling the application up front. You compile it as it executes. You avoid paying that compilation cost up front, and you just in some ways, you amortize the cost of the compilation of the app to runtime. So you just like delay it and only compile the parts that are actually executed on the device. So that's an attractive way, especially in a development setup where you prefer not to have to wait like 30 seconds. So let me show you how that actually works and why this is a key component in making Dart really useful for Flutter. And this also will give you, like, hopefully, a chance to see Flutter in action with some real code. So let's try it. I don't want to do everything from the command line here, so we have good integration with IntelliJ and Android Studio as well. So if you want to try out Flutter and try to write some code in it, and you're familiar with those tools, it's kind of easy to install a plugin for the IDE and get going from there. So let me try that out in practice. That was the IntelliJ. So before we do anything, let's just check we still have this floating around. So this is the code for a very, very simple app. And we can start running it in the background. And you'll see a giant console pop up here. See if we can resize this a bit. And essentially, it's doing what you saw before. It's using Gradle, it's building everything, it's installing an APK over there. Hopefully, at some point, it will fire this app up. Give me a few warnings, and then at some point, we'll see a thing on the screen over there. Demo and account, and it might be hard to see in the back, but we'll fix that shortly. I just want to tell you a bit about the structure of a simple app written in Flutter. So in Flutter, everything is a widget. It's widgets that are composed of other widgets all the way down. So if you want to build an app, you will build essentially an app widget. In this case, we have this demo app thing that extends a stateless widget. It doesn't have a state of its own, so stateless is just the right choice. And the way it then works is that the framework will call a build method on that widget to tell it how to render, how to map the current state to the representation of this thing. And in this case, the demo app just says that when I'm building myself, I just return a new material app, which is also a widget, that has a homepage that is defined below. So material app is another widget, and homepage is another widget, so it's widgets all the way down. Homepage is actually stateful. It contains a state, so In Flutter, the widgets and the state that they refer to is separate because they have different lifetimes. The state can outlive the widget, and that happens quite often. So they're split in this way. Like you have a specific way of creating state, and then most of the logic fits in the state object below. So the state, homepage state is the interesting one. It has a count. In this case, it's initialized as 0. It has a way to increment the counter, and it has a build method here that, as you remember from just before, the purpose is to map the current state to a tree of widgets, hopefully simpler widgets than what the whole homepage is supposed to be. In this case, it's a scaffold with an app part that says demo. It has a body that's centered. In there's a child that is some piece of text that says here. The text is supposed to actually contain the count. And if you can see it from the back, it actually says count:0 over there. I can click the button. There's a floating action button at the bottom. And on press, this will call increment counter, which is defined above. And all it does is increase the count. It doesn't manipulate the UI at all. It just says, I'm changing the state, I'm updating count, and please re-invoke the build method and get a new representation of this thing. So let me try to click this plus thing. You get some counts there. And as I said, it might be kind of hard for you in the back to see this count. So let's try to change this, this thing, and we'll add a style. And we'll do font size 32 or something. So we can then go ahead and save that. And then what we can do is we can actually say, I'd like to see this performed live on the current, in the current emulator. And it will say initializing hot reload, and it will do the change right there. The nice thing is it's a state-preserving hot reload. So that means that I'm reloading the application code. But the really nice thing is that I don't have to do anything. The state's preserved, but I still get the new UI. So that means I can play with the UI, and I can change it in a much more fundamental way with refactorings and everything you'd like. So we could take this text thing and say, let's do a refactoring here and say, if I can find it, refactor here, extract to a variable. That's the thing I want. And then we'll call it contents. We can say that. And then we can do a hot reload again and see if that worked. Nothing changed. You see here now, after the first hot reload, we're reloading this entire app, seeing the UI changes reflected on the real emulator in 550 milliseconds. That's pretty good. I think as long as you're below a second, this feels fluid. This is certainly not waiting 30 seconds for a compiler or 2 minutes for a compiler to do its work. So that means that you can actually use sort of generic programming constructs to build your app, and you use sort of simple code, if statements and whatnot, to construct and adapt your UI based on the state. So we could go ahead and say if the count is actually 0, we'll replace the contents with like something simpler that says welcome instead. Press button, something like that. We can save that, and we can then say do the hot reload. Clearly, the count is not 0 right now. It's still 11. So maybe I have to actually start it over instead. But starting over, like a full restart, also only takes like 700 milliseconds here. So even that is not too painful. It's not a real compile from scratch. The way it works is that the just-in-time compiler is making sure that we only compile what's needed on the device as you go. And that's great for development. So now you see welcome, press button. And once you start pressing it, you see the count increasing. Of course, you can set breakpoints and everything in this because it's just code. So you can work with this the way you would usually. I think the final point with this, and this also works with the iOS emulator and devices, is that the way it's constructed is that we'll call these build methods quite a lot. And basically what they do is just allocate a new tree of widgets below. And there's certainly some people that enjoy this model and really find that it's a super useful model. But we also find people that get a little bit concerned with this model. So the reason why they're concerned is that that seems expensive. Like having a model that fundamentally just recalls this build method and reallocates this big widget tree, that seems too expensive. So the question is really, like, is this too many objects? Like constructing widget trees in Flutter, is that expensive? And to explain why it's actually not expensive, I'll have to talk a little bit about garbage collection and allocation in Dart. So the way it works is that you have no problem with the widget trees. You can go ahead and create many of them, and the reason why you can do that is that our allocation is super fast and our garbage collection is too. The way allocation works in Dart is it's really, really simple. So we make sure that we have free space that's contiguous. So that means that allocating an object in this free space is just bumping a pointer, and that actually allocates that chunk, the light gray here. The only thing you have to do in order for this object to be done is to initialize the allocated space, and you have an object. So it's very, very cheap and very simple, as long as you have contiguous space at the end. So in Dart, allocation is log-free. It's simple and it's really fast. So that means that the construction part of this is kind of trivial for us to make fast. Some people end up using like malloc or things like that, and often these go through like free lists and whatnot, and that actually comes with a big price. Like searching for a suitable place to allocate can be quite expensive. Here it's really that simple. All it requires is that our free space can be in a contiguous area. So how do you make that happen? How much do you have to pay for collecting the garbage and get to a point where you actually have free space in that way? Well, you don't have to pay much. It's not that complicated. And what I'm telling you now is not unique to Dart. This exists in many other systems, and it builds on some very classical old algorithms from the early 70s. Most good things are from the 70s, and especially in the garbage collection. There are lots of really, really cool things from that era. So I'll teach you a little bit about how garbage collection works. Like, how many people here know what a garbage collector is? Lots of people know that. How many people have implemented one? That's really neat. Maybe you guys don't have to hear this then. This should be fine. Anyway, so the real trick with a garbage collector is knowing where the pointers are. For us to identify which objects are garbage and which objects are still alive, you need to know what refers to what. And there are two approaches. One is what we call conservative, and that's a fairly simple idea. Everything that looks like a pointer in memory, like any location in memory that looks like a pointer, we'll treat that as a pointer. So that means that if something refers to, has a bit pattern that makes it look, it could be a pointer to something else, let's treat it as a pointer. That's very simple in some ways, but it also means that you can't distinguish integers from pointers. Like, that could be an integer that happens to have a value that would allow it to point to a specific memory location where an object could live. And that means that you can't update pointers. You can't change it, because what happens if you change a pointer that happens to actually not be a pointer but be an integer? Then suddenly your integers in your program will change value without you controlling it. That doesn't work. So it's attractive to go to a model that is what we call precise. This is what we use in Dart. And in a Dart setting, we know where all the pointers are, so that means that we can update them. And that's key to actually having a fast allocation. So the way we allocate objects in Dart is that we have this contiguous area, and once that's filled up, we start doing a simple semi-space collection of the garbage. The reason why it's called semi-space collection is that there are two areas. One is the area where the current live objects live. In this case, all the dark gray matter here is dead objects, things that are not supposed to survive. And there's a corresponding to-space where we will copy these things over. So the way a semi-space collector works is by copying only the live things over, one by one. Copy all the objects over to the to-space. When you're done with that, you have all the live objects in the to-space, and you can go ahead and actually clear the from space and be ready for another garbage collection where you then copy them back in the other direction. You swap the to and from space, and you're ready for that. That actually means that because you move these things over, all your free space is now in one chunk, and this is where you can allocate really quickly. Does that make sense? It's fairly high level, but it's still a really neat sort of small technique, and it really builds on the fact that you have precise GC that allows you to move these objects. Without precise GC, if you don't know where the pointers are, you can't move these things, and this doesn't work. And this is where you would copy them back then. So Dart uses a precise garbage collector. And the idea is that it allows moving objects, and more importantly, it allows you to start compacting things. So it enables the fast allocations, but it also enables really fast garbage collections. I will now walk you through what a garbage collector does really quickly in like 7 slides. Here is an object graph of all the live objects in the system. There is some root probably on the execution stack or in some static field somewhere that refers to one object that refers to some other objects in return. And there's tons of dead objects that are not referring to anything, maybe each other, but doesn't really matter. Like, the live objects are the ones with a slightly more interesting color here. So the way it works is that we want to copy the live things to the to-space. And what we do is that we get ready for that to-space and we start copying over the object starting from the root. So we look at the root and we look at that pointer to the first object and say, let's copy that object over. So we do that. And because we copied the object over, then we also copied a reference. So now we actually have two gray objects that are in the system in a sense, and they both refer to the same green object in this case, just because of the copy. Once we've done this copy, we can install what we call a forwarding pointer, remembering that we've already copied this over, and we can update the roots pointer to this new thing. Now we're not done yet, but we've started moving things over to a new space, and we can continue on that. So the way we then continue is that we start scanning through the to-space, we run through this object, and we find pointers from the new to-space that goes back into the old system. And there's a pointer here that points to the green object. We need that to be updated. In order to update that, we copy the green object. So that goes here. Once you copy that, you also copy the pointer that it has to the blue object with you. So there's still more work to do. But you can actually go ahead and install the forwarding pointer in the green object, and you can go ahead and add this reference there. So we're making progress here, but there's still a reference to the blue object. You continue the same way. Reference back, let's treat that. Copy the blue object over. Then still have a reference back to the green object. Update the pointer, insert the forwarding pointer, and then you have the three objects over there. But you still have this one pointer that goes back to the green object. That is easy to fix because we already have a forwarding pointer for that green thing. It's already been copied, so you just follow that and get the final result where these things are updated. This is sort of a really quick way of just running through a garbage collection, but the most important thing here is that, first of all, we're done. There's nothing left to do, but we also never touched any of the dead objects. We never looked at them, we never ran through them, we never asked them how many pointers they have. We don't care about them. So essentially, we don't have to worry about them. They have zero cost. And they just go away, and you have the new system here. They're easy to allocate from, and off you go. I should really tell you about generation garbage collection now, but that would probably be too much, because what this really shows you is just that for short-lived objects, the first generation in a real system, you have this behavior that you have zero cost for dead objects. That means that collecting a tree of widgets that's not used anymore is free. It's a non-recursive implementation that makes it fast and simple, and that's a really good quality to have for a garbage collector. So Flutter's widget construction pattern is super well supported by Dart, and that really makes a difference for real apps. So Dart for Flutter, in a nutshell, allows you to deploy fast machine code. It allows you to have this hot reload in a development setup where you don't have to wait for the compiler. You can treat the UI as sort of live code. It's really nice. And it efficiently deals with tons of widgets. Let's return to the Hamilton thing and see how that actually worked out for them. So after 3 months, this Hamilton team, they built 2 apps, one for Android and iOS, using a single code base. And I think 3 months is a pretty reasonable target for this kind of thing. They actually shipped it to both the Android Play Store and the iOS App Store to great reviews and multi-million installs. I don't think it's probably not that hot here in Europe. I think the show is coming to London next year or late this year, but we probably don't have many people installed this year. I have it on my phone, so if you want to see it, you should find me afterwards. But the core of it is that they can build a real production app with this system in record time and ship it and get great reviews from it, and so can you, of course. So Flutter makes it easy to build beautiful apps in a quick way. It's a new mobile SDK. It's available right now in an open source alpha release. The reason why we call it alpha is not because of the quality of it, it's because there are some missing pieces that we'd like to finish before we call it a beta or a 1.0. But the bits that are there are really high quality. The things that you might be missing if you start using it today are things like accessibility, where we're still working on finishing that. And that's important for certain classes of apps. It is actually used by people at Google, but certainly also others, and even people in this audience here who have played with it and uploaded real apps based on it. So it's a real thing. We're still hacking on it and making it even better, but it's definitely ready for more fun to be had with you guys. So that's it. Thank you. And if we have questions, and we probably do, then we can probably switch over and I'll try to answer them.
Thank you so much, Kasper. Do we have any questions from the audience right now? Okay, so we're going to switch to Slidey because there's a lot of questions.
Many questions, that's good.
Many questions. Actually, there's one I would like to answer by myself. If we are using Flutter for our DevFest app, The company responsible for the app is eMan, and they have the partner stand in the other building where all the partners are, so you can ask them actually directly. And now we're gonna start with some most popular for Kasper.
We'll try it at least. Let's see if we can get them up here. So we actually have at least one DevFest app out there in the world that was written in Flutter, somewhere in the US. So it does exist. The first question is, any thought on Xamarin? You can see it up here. I actually have not used Xamarin that much myself, so I do have lots of thoughts about it, and I know a great deal about how the technology works. I think that one of the areas where we hear from most people that Xamarin gets a little bit hard is once you start going into custom UIs. I think the model that they have and the language that they have work pretty well for them. So I think that's another pretty good bet on that for a cross-platform toolkit. Flutter is very different in its framework and the way it works. So I think it's probably a matter of trying to find the right technology for the kind of problems that you're trying to solve. There's a question about low-level API support, and that's actually a really good question. So imagine that you want to get something simple as GPS or battery level or even more complicated things into your app, and that's provided by the underlying platforms. How do you go about doing that? So the way we built that is we have a concept of plugins for Flutter, where you can install platform native code, like Java code or Swift code or Objective-C or even Kotlin code in there, and just expose an API from that through a messaging protocol. And we have a repository of already written plugins for these things, and that's growing very nicely. That means that there are plugins for Firebase, and plugins for lots of things, where it's the best way for us to build that is actually just take the native code that already exists for that platform, pull it into the project, and expose a simpler API for it. So the way you have low-level APIs available in this context is that you write a sort of a message passing facade for it, and you expose that to both platforms. Some people find that a little bit painful to have to expose a new API on top. We find that that's almost necessary if you want to deal with the differences between the two platforms anyway. But clearly, if you're just addressing one platform, there is some overhead in just writing that thing. For most people, the plugins will probably just be there in the ecosystem. You just grab hold of them and use them. That's the easy answer, I think. Do I still need a Mac OS computer to build the iOS variant of the application? I think that's the case, yes. As you saw, we use Xcode as our way to build the app, but also the way to sign them and get them uploaded to the emulator and eventually to the App Store. And that only works on a Mac. I've heard that there are people out there that are trying different approaches to that. It would be great if we could have a way to build Android apps and iOS apps from, say, Linux or even Windows, but I don't think it's quite there yet. Certainly, I know lots of people inside Google that would really love to be able to use their Linux workstation and still just work for Mac, for iOS, sorry. And then there's a question about Kotlin native. I think actually Kotlin native is kind of an interesting question. And that's going to be the last question here. The rest will be out here. So Kotlin native is a new technology from the JetBrains team. It looks really cool. I think it's based on LLVM. So that means that the way they generate native code is through the LLVM compiler infrastructure. One of the challenges there is that it's hard to do precise garbage collection in that context. Hard, maybe not impossible in the future, but right now it's kind of hard. So most of these systems here end up with a conservative garbage collection, and that does have some implications on the kind of frameworks that are well supported by the stack. I'm sure that we'll see much more greatness from that team in the future. But right now, I think that's one of the things that Dart does really, really well, and it's really, really important to Flutter. Also, the hot reloading is kind of hard to do with an LLVM-based stack. So those are two major areas where I think Dart does really well today. I think that's all the time we had. Thank you so much for attending here, and if you have more questions, I'll be right out here.